Friends, welcome to the spoken tutorial on PVT surface for pure substance that contacts on freezing. This spoken tutorial is developed at NRI Institute of Information Science and Technology, Bhopal. In this spoken tutorial, we will try to understand PVT surface for pure substance that contracts on freezing by the help of a 3D model made in AutoCAD. Prerequisites for understanding of this spoken tutorial are a thorough understanding of properties of pure substance, PV diagram of pure substance, TV diagram of pure substance, PT diagram of pure substance, and definition of basic terms relevant to behavior of a pure substance. This is the 3D model of PVT surface for a pure substance that contracts on solidifying. It is clear from 3D model that pressure, specific volume and temperature are plotted on three mutually perpendicular axis. This whole is the PVT surface of the pure substance that contracts on freezing. And the significance of PVT surface of a pure substance is all possible equilibrium states of the pure substance are represented by a point on this PVT surface of the pure substance. Let me now start the explanation of model of PVT surface of pure substance, first by explaining different surfaces involved in the making of this model. The green colored surface TUVY indicates various possible equilibrium states of the pure substance when it is in solid phase. The orange colored surface PCIL MJS indicates various possible equilibrium states of the pure substance in liquid state. One thing I would like to add here is at pressures higher than critical pressure, the differentiation between gas and liquid should not be taken very seriously, because at pressures more than critical pressure, for a pure substance, liquid and vapor phase never coexist in equilibrium, and we can call the pure substance simply a fluid. The cream colored phase RAGKLHBQ indicates various possible equilibrium states of the pure substance in vapor phase. Here I would like to add one thing, that the boundary line between vapor and gas should not be taken very seriously, because gas is simply a name for superheated vapors. The yellow colored surface KNWXOMLK indicates various possible equilibrium states of the pure substance in gaseous state. The light blue colored phase PSTU indicates various possible equilibrium states of the pure substance when it is in two-phase solid liquid region. The dark blue colored surface RQUVR indicates various possible equilibrium states of the pure substance when it is in the two-phase solid vapor region. The pink colored surface QBHLICPQ indicates various possible equilibrium states of the pure substance when it is in the two-phase liquid vapor region. Lines of constant temperature plotted on PVT surface are called isotherms. On the 3D model of the PVT surface of the pure substance, you can see the isotherm A, B, C, D, E, F. You can see the isotherm G, H, I, J. You can see the isotherm K, L, M, and you can see the isotherm NO. LICP is called the saturated liquid line, and LHBQ is called the saturated vapor line. Let me now develop a connection between 3D model of PVT surface and 2D PV diagram, PT diagram and TV diagram. The PT diagram for pure substance that contacts on freezing is shown here. This is the axis of pressure, this is the axis of temperature. This is solid phase area, this is liquid phase area, and this is vapor phase area. And if you look at the model of PVT surface from right side, you will see the PT diagram. Let me show it to you. Suppose this is front direction of looking, this is top direction of looking, and then this direction will be right direction of looking. And when you look at the 3D model of PVT surface from right side, you see that it appears similar to the PT diagram. This is the axis of pressure, this is the axis of temperature, this is the triple point, this is the critical point, this is the solid region, this is the liquid region, this is the vapor region. Once more, I have brought the slide of PT diagram on screen so that comparison becomes very clear in your brain. This is the PV diagram for pure substance that contacts on freezing. This is axis of pressure, this is axis of volume, this is the critical point, and these are isothermals plotted on the pressure volume diagram. If you look at our 3D model of PVT surface from front direction, it will appear same. Let me now demonstrate it. Now you are looking at the 3D model of PVT surface from front direction, and its view is same as the PV diagram shown in the slide. I am bringing slide once more on the screen so that comparison becomes very clear. Similarly, if you want to see the TV diagram of pure substance, you will simply look this 3D model of PVT surface of pure substance from top. Let me look at this model from top. This is the axis of temperature and this is the axis of specific volume. And this is the TV diagram for a pure substance. Let us now try to understand behavior of pure substance by the help of 3D model of PVT surface for pure substance that contacts on freezing. Let us start by isotherm On. For isotherm On, temperature is more than critical temperature, and therefore we can call the pure substance to be a gas. If temperature is more than twice the critical temperature, then gas starts behaving as an ideal gas, and in that case isothermal On will be a rectangular hyperbola. Isotherm KLM is the critical isotherm. State point L gives us the value of critical pressure, critical temperature and critical specific volume for the pure substance. At critical point, saturated liquid and saturated vapor states are identical and there is no latent heat of vaporization, or we can say latent heat of vaporization is zero at critical point. Isotherm A, B, C, D, E, F represents temperature higher than triple point temperature but lower than critical temperature. At state point F, the pure substance is in solid state. As pressure reduces, there is a very little increase in specific volume until we reach the state point E where the melting starts. ED is constant pressure, constant temperature melting process in which change of phase from solid to liquid takes place until D is reached. At D, the melting process gets completed. On further decrease of pressure, there is very little increase in specific volume until state C is reached. Cb is constant temperature, constant pressure vaporization process in which change of phase from liquid to vapor takes place. B2A represents superheated vapor region. Let us now try to understand how triple point appears in a 3D model for PVT surfaces. Triple point of pressure temperature diagram appears as a triple line in the PVT surface model. The reason is for triple point the pressure is fixed and temperature is fixed. Specific volume varies depending on proportion of each phase. This is the sublimation line in the PT diagram, and let us observe how it appears in the PVT surface model. It is interesting to observe that the sublimation line appears as a surface RQUV in the PVT surface model. There are a lot more things to be covered, but since there is time limit for spoken tutorial, I stop here. Thanks for watching.